Using the newly learned computational formula, we need to find the sample standard deviation for this data. First, let's just list the scores in increasing order: 9, 21, 45, 51, and 54. Now, the first sum will be the sum of the score. That's the sigma xi. Second column, we're going to square them. 9 squared, 81. 21 squared, 441. 45 squared, 2025. 51 squared, 2601. And 54 squared, 2916. Now this sum will be the sum of the square, and the sum of the squares is equal to 8064. Now we need to calculate the square of the sum divided by n. We're going to calculate the square of the sum. This is the sum. We're going to square it and divide it by n. It's going to be 180 squared divided by n, which is 5. Now, 180 squared is equal to 32,400 divided by 5. Now our final answer is going to be 6,480. The sample standard deviation will be equal to the square root of the sum of the squares, which is 8064, minus the square of the sum divided by n, which is 6,480, divided by n minus 1, which is 4. And we get an approximation of 19.9. The 3 standard deviation rule says that almost all the observations in any data set lie within 3 standard deviations to either side of the mean. Now, almost all the observation is not really precise. It's too vague, and we don't know what it means. Chebyshev's rule says at least 89% of the data will fall within 3 standard deviation of the means. And the empirical rule says that for a bell-shaped curve, 99.7% of the data fall within 3 standard deviation of the mean.